Welcome back to the channel. Have you ever wondered how Netflix recommends your favorite movies? How Amazon suggests products you might like? Or how Google Maps predicts traffic before you even start your journey? The answer behind all these smart technologies is data science. In today's video, we will understand what is data science, why is it important, real world applications, then components of data science life cycle, skills required to become data scientist, and career opportunities in data science. So let's get started. In this topic, Introduction to Data Science, we will see Introduction to Data Science, different sectors using data science, purpose and components of Python, data analytics process, exploratory data analysis, and the types of exploratory data analysis. So what is data science? Data science is the process of collecting, then cleaning, analyzing, interpreting, and visualizing the data. So, what is the purpose? To discover patterns, make predictions, and support decision making. When we talk about data science, it turns data into information. It will analyze the data to get insights. Then, with the data science, we can identify trends, correlations, and patterns in the data and contextualizing, applying, and understanding the patterns in the data. Data science is an interdisciplinary field where we have three different domains, combination of three different domains in data science. So here, first domain that we have is statistics. Second, we have computer science, and third, we have business domain. So or business knowledge, we can call it as a data science is in the center, which is intersecting all these three domains. So, first, when we talk about statistics, it is understanding data patterns and relationships. We can use statistics to do these things. Then, second, computer science, it is used for processing and analyzing the large data sets. And last, business knowledge or domain knowledge, it is used for asking the right questions and interpreting the results. So, even though it is interdisciplinary field, the most important thing in this is a data without which we cannot do anything. So we will understand what is data now. So let us talk about the data. Data is the raw material. It is collection of facts, numbers, or information. It can be of three types. First, we are having structured type. Second, semi-structured, and third, unstructured data. We'll understand one by one each type. Structured data is the data which is organized in the form of tables, which is having rows and columns format. Like examples are Excel spreadsheets or SQL databases. When we talk about unstructured data, so there is no fixed format. So the data is not available in tabular format specifically. So examples are text, images, videos, audio, then social media post. These are examples of unstructured data. In between these two, we are having semi-structured data, which is partially organized, and it is the data which can be converted into tabular format or and column formats. So examples are JSON format, XML, that is extended markup language, or log files. So we have talked about the data in the data science. Now we will talk about the science part of data science. It is nothing but a method of discovery. In data science, we always apply scientific method for the data. So we'll understand the step-by-step process. First step is asking a question. Second, collecting and cleaning the data. Analyze and explore. Model and predict, and then communicate the results. So this is the method or process in data science whenever we are applying scientific method for the for generating insights from the data. In case of asking a question, for example, if I'm doing some operations on the student data, I can say, do students who study more get better grades? This is my problem. Okay. I will collect and collect the data related to the student records or students' marks, and then I will clean these particular records. So I will gather exam scores and then study hours of the student, and uh, we can also clean the data. Then analyzing and exploring, look for patterns and visualize the trends in the data. In model and predict, we'll use statistical and mathematical operations and functions to find relationship between different variables available in the data, and then communicating the results to the stakeholders. That is, explain the findings in simple terms to the stakeholders. So this is nothing but a method of discovery, that is science. So putting together data and science will get the data science. It is the art and science of extracting meaningful insights from the data using first statistics to find the patterns, second programming languages to process large data sets, and third machine learning to make predictions, and last visualization to tell the stories with the data. Now these are few examples of real world examples. Like first Netflix recommendations, you might be using Netflix in your day-to-day life. Second, fraud detection in banking, and then healthcare predictions. So we will see what is data and science in these examples. So when we talk about Netflix recommendations, so data is what you watch and science is predicts what you will like. In fraud detection in banking, data is transaction history and science is flags of unusual activities that are happening on the transactions. In healthcare predictions, data is patient records and science is predicting the disease risk in using the data. So a simple analogy, we can think of data science as a detective where data is equal to clues, like for example, fingerprints, witness statements. Science is like investigation methods where we have logic and experimentations, and insights, that is solving the mystery, that is nothing but finding the answer to your questions. So we can say that data science turns raw data into useful knowledge. Let us consider a short case study example for data science, that is pizza delivery time prediction. Will predict the time required to deliver the pizza. There is a small data set for this particular example. Like consider you work for a pizza shop and you want to predict how long deliveries will take based on the past data to reach the destination. So the step one that we can use asking a question. Does the distance to customer's house affect delivery time? This is the question. And this is also a problem that we want to solve. So how, with the help of solution of this problem, we are going to analyze whether how much time it is taking and what are the different factors which are affecting the delivery time required to reach to the customer's house as per the distance. Second step, we need to collect the data here. So a small data set of last week's deliveries as given below. First, we are having order. Second, we have distance in kilometer and then delivery time in minutes. So there are five records in this data set. First, we are having distance 2 kilometer. For that, 15 minutes required to reach our delivery time. For 5 kilometer, delivery time is at 25 minutes. For 1 kilometer, 10 minutes. 4 kilometer 20, and for 8 kilometer it is 40 minutes. So this is the distance values, and these are the delivery time values we are having in the data set. Let us go to the next step, that is explore the data where we will be considering the different parameters or attributes in the data set, like distance, which is increasing, and delivery time is also increasing, that we have observed in the table. So on an average, each extra kilometer adds 5 minutes. So whenever 1 kilometer is increasing, it will add 5 minutes to reach to the particular customer's house. Then in the next step, that is step 4, we will build simple model, uh, which is nothing but a with the help of math or statistics, we will frame the equation. So we are going to calculate the delivery time in minutes, and we are having input as a distance in kilometer. So 5 multiplied by distance plus 5. So plus 5 we are adding for packaging time or any other time required to reach to the customer's house. So to check whether this particular model is working properly, so we will have these examples like if we are having a distance as a 3 kilometer, we want to reach for 3 kilometer. At that time, we can solve this equation like 5 multiplied by 3 plus 5. So 20 minutes will be required. Then next for 10 kilometer, 5 multiplied by 10 plus 5. So 55 minutes will be required. So traffic may slow the delivery time also. So this is step number 4 where we have built our simple model. Then step 5 is communicating the results or communicating the insights. So we can say that from the overall model that delivery time grows by 5 minutes per kilometer. For long distances, we may consider faster drivers. So this is the insight that we got from this particular scenario. So we are also having examples of real companies like Uber Eats and Domino's. So they are using this with the help of AI. Okay? And the same core idea is used by these industries for delivery of food products. Now let us move to the next part. That is, what does a data scientist do? What are the activities of data scientist? So the first, data scientist will be involved in data collection and processing of data. So data scientist will convert data from raw format to a cleaner format. Second, calculate and interpret. That is, calculate and interpret statistical variables with the help of statistical operations and mathematics. Next, visualize and conclude. That is, creating visualizations and drawing conclusions for the analysis. And then build and suggest, where suggest applications and develop machine learning algorithms. These are the day-to-day life of a data scientist. Then we will understand the difference between data and information. It is very important to correlate what is data and what is information in relation to the data science. So when we talk about data, it is nothing but a raw, unorganized facts like numbers, text, images without context. So data will not be having any context. And the examples are like there are numbers 27, 15, 32, 42. So we are not getting any meaning out of these numbers. Second, color, blue, red, green. We are not understanding for what purpose these colors are written here. And then next, we have the floating numbers, that is floating point numbers 5.5, 6.0, 4.2. Again, we do not understand the purpose of writing this or having this particular data. So that's why there is no context. This data is without context. And when we talk about information, it is processed, organized data that provides context and answers to the questions. So examples include temperatures this week, 27 degrees Celsius, 15 degrees Celsius, 36, 42 degrees Celsius. So these are the data which are having context and we are getting meaning out of this. That's why we can call it as a information. But data is not equal to information. Data and information are not same. Data is different and information is different. So if we are saying data and information are different, we need to check how we can convert data into the information. So we'll see how data becomes information. First of all, we will collect the raw data or gather the raw data from the survey responses, sensor readings, or any other source. Second, processing that data. In processing, we can clean, filter, and organize the data where we will remove errors, we will fill missing values. Next step, analysis, that is finding the patterns, averages, trends, and correlations in the data. Then last, interpretation, turning the results into insights. That is Like one example we can consider, sales drop on days. This is nothing but an interpretation. So in this way, we can convert data into the information. Now we will see the difference between data and information. So when we talk about data, it is unorganized and unrefined facts, and information is processed, organized data, and presenting with the meaningful context. An individual unit of raw material that carries no specific meaning is data. But a group of data that collectively carries logical meaning is nothing but a information. It doesn't, that is, data doesn't depend on information, but information depends on the data. Data is insufficient alone for decision making, but whenever we are going to take any decision, information is sufficient. Example includes for data, a student's test score, and in information, we are having average score of class, which is giving us information or meaningful insights of the data. Then, when we see the concept of data, there is one more concept associated with the data, that is big data, where we are collecting large amount of data. So big data refers to extremely large and complex data sets that traditional tools can't handle. Okay. So we have traditional tools like Excel, Microsoft. So it cannot handle the big data. It's not just about size, it's about how fast data grows and how varied data we are going to collect. So it also refers extremely large and diverse collections of structured, unstructured, and semi-structured data that continues to grow exponentially over the time. Big data is any data that is expensive to manage and hard to extract value from the given data. There are three important V's of big data. First is volume, which indicates size of the data being generated and stored. So large amount of data being generated and stored in the big data. Second, velocity. Velocity indicates the speed of data processing relative to the growing demands for the interactivity. Third, variety and complexity of the data, diversity of sources from which data is generated, different formats of data, quality and structures of the data. So these are the three important V's of big. Now, big data and data science. We will see how these are in related or relation with each other. So first, when we talk about the data science, data is coming from various sources like online purchases, multimedia instruments, financial logs and sensors, text files, and many more. Data might be structured, semi-structured, or unstructured. We already have seen what is structured, semi-structured, and unstructured. Together, this is called as big data. Putting big data to good use is pressing job of 21st century. So data science is not one tool, skill, or method. It is scientific approach using applied and statistical mathematical theory plus computer tools to process the big data. The result is the data scientist's ability to capture, maintain, and prepare big data for intelligent analysis. Now we'll see the different sectors using data science. So the first sector is automotive and transportation, where we'll see the use of data science in self-driving cars for route optimization and predictive maintenance. So examples like Uber uses big data to match drivers and riders efficiently. Second, social media and entertainment, where content personalization, sentiment analysis, advertisement targeting. YouTube is the one of the example which will we are using today and nowadays. Recommendations drive 70% of watch time in the YouTubes. Next is example agricultural, where precision farming, crop prediction, pest control via image recognition is done. Like industries like John Deere uses AI to optimize harvest with 20% less water. Then in government and public sector for crime prediction, disaster response and smart cities project. we can use data science. Example like Singapore uses big data for urban planning and pollution control. Next sector is education, where data science can be used for adaptive learning, dropout prediction, and automated grading. The platform that is Duolingo's AI tailors lessons to user performance. Another example is Khan Academy, also using AI for education. Next sector is the energy and utilities, where data science can be used for smart grids, predictive maintenance, energy optimization. One of the example is DeepMind reduced data center cooling cost by 40%. So we can say key takeaways for these particular sectors using data science is almost every industry now relies on data science for efficiency, personalization, and prediction. Next topic is Python in data science. So why Python dominates the data science? Because Python is a programming language which generally is used for data science. Thanks to the simplicity, versatility, and powerful libraries available in the Python. So why we are using Python? The first reason is easy, it is easy to learn and read. It is having very simple syntax and closer to human language like C and C++. It is having rich ecosystem of inbuilt packages or libraries uh, which can be used for every data science task. Then it works with big data, which we can integrate Python with Hadoop, Spark, and SQL databases. It is having strong community, free tutorials, and active forums where we have support of data science projects as well as machine learning projects. We are having platforms like Kaggle, Stack Overflow, and GitHub. Then automation and scalability. Uh, with Python, we can automate the task and deploy models to production environment, like using Flask and Django. These are the few core Python libraries for data science. Those we can use for data handling. We can use the Pandas and NumPy package, and for visualization, we can use Matplot, Seaborn, and Plotly. For machine learning, Scikit-learn, XGBoost, TensorFlow. For NLP, that is natural language processing, NLTK is important package, Spacy and Hugging Face platform. Then for big data and cloud, we are having PySpark, DAS, AWS GCP, SDKs. This kind of environment can be handled with the help of Python packages. We will now see how this real world workflow can be built, how it all fits together. So first task we have is data collection, where we can use Python packages like Pandas, then databases, SQL Alchemy for data collection. Second task, cleaning and exploration. For this again, Pandas, NumPy, and Seaborn packages can be used. For model building or model training, we can use the Python packages Scikit-learn, TensorFlow. And for deployment, we have Flask, Fast APIs, and AWS Lambda services. So this is how we can fit the data science and Python with each other. Then next topic is data analytics process, where we will see what is data analysis and data analytics. So when we talk about data analysis, it is the process of inspecting, cleaning, transforming, and modeling data for what? To discover useful information, draw conclusions, and support decision making. These are the important things. A crucial skill across the business, healthcare, finance, and technology. So this is nothing but a data analysis. What is data analytics? It is something different from previous. It is process of examining, cleaning, transforming, and interpreting data to uncover patterns, trends, insights that drive the decision making, where we will convert raw data into actionable insights. That is nothing but a data analytics. So we have understood what is data analytics. So there are different types of data analytics we can see. So there are four types of data analytics. First, we have descriptive. Second, we have diagnostic, predictive, and prescriptive. We will understand each type with the example. So first, descriptive. The role of descriptive type of and data analytics is summarize the data. It will summarize the data or describe the data. What is the purpose? To check what happened. Okay. Then example includes how many sales occurred last quarter, which will give us the summary of the data of the sales that occurred last quarter. The tools used in this particular type of analytics is a SQL, Excel, and Tableau we can use. Second type of diagnostic is a second type of data analytics is diagnostics, which will provide us logic behind, or we can say reasoning. Okay. So, what is the purpose? Why did happen? Why something has happened? Example question: why did sales drop in the December? We will try to identify the reasoning, and then the tools or techniques used are correlation analysis and drill downs. We can use for diagnostic purpose. Predictive: this is nothing but a prediction for future we can do with the help of this type of data analytics. So the question that is purpose is what will happen in the future. Example, will sales rise next month? Means we are doing prediction here for future next month. And the techniques that can be used are regression from machine learning and the package that is tools, scikit-learn we can use. Then last data analytics type is the prescriptive, which will indicate the action to be taken. So the purpose, what should we do? So the question, should we offer discounts to boost sales? Okay. Based on the descriptive diagnostic analytics, we need to decide what kind of actions we can take in the future to boost the sales. So whether we can offer the discounts that we need to check. Tools and techniques used are optimization models and A/B testing. So these are the types of data analytics, but everything that we are doing, whatever type we are applying, the main thing behind that is a data. We need to have data. Based on the data, we can carry out this kind of operations. Then there is a data analytics process where we will have different steps. Like first, we need to define the objective. What problem are we solving? Then second step is data collection, where we will have data sets, databases, APIs, web scraping techniques for collecting the data. Third step is data cleaning, where we will handle missing values and outliers in the data, that is data pre-processing. Then next we have exploratory data analysis, that is EDA, where we will visualize the trends and statistics in the data. Modeling and analysis step, where we have statistical test, machine learning algorithms. And then last, interpret and share, where we will have dashboards and reports of the final analysis of the data that we have collected. Then next, tools for data analytics. So first, programming. We can use Python and R programming for data analytics. Second, we have data visualization, and for this we can use Power BI, Tableau, Matplotlib, and Seaborn are Python packages. Those also can be used. Then big data like SQL, Spark, Hadoop can be used for data analytics. And then for business intelligence part, we can use Excel, Google Sheets, and Looker. So these are the tools for data analytics. Those we can use. We will differentiate data analytics and data science now. So when we talk about data analytics, it will focus on past and present data, whereas data science talk about the future predictions. In data analytics, we are having tools like Excel, SQL, Tableau, Power BI. In data science, we have tools like Python, TensorFlow, and Spark. Then in data analytics, the goal is answer business questions, and in data science, goal is to build automated decision systems. So data analytics tells us what happened and why, and data science tells us what will happen and how do we act to this. So these are the distinctions, differentiations between data analytics and data science. Next, we have next topic as exploratory data analysis. It is the first step in data analysis where we investigate data sets or databases to summarize the main characteristics, to detect patterns, anomalies, and relationships in the data, test assumptions with visual and statistical methods. These things we can do with the help of exploratory data analysis. So we can say that it will act as a detective. We are searching for clues in the data with the help of EDA. Then next, why EDA is important, that we'll understand. So to understand the data structures like variables and missing values, we will need the help of exploratory data analysis. Spot data quality issues, that is outliers and inconsistencies can be identified with the help of EDA. EDA can also be used for identification of relationships between the different variables, and it will guide feature selection for machine learning, and it will validate the assumptions before complex modeling. So that's why exploratory data analysis is very important. These are the few key aspects of exploratory data analysis. First, we have distribution of data that can be done or seen with the help of central tendencies like mean, median, mode. Then dispersion, measures of dispersions, variations and standard deviation and range. Second, graphical representation, where we can use histograms, box plots, scatter plots, and bar charts for visualization of the data. Then outlier detection can be done in exploratory data analysis, where we will identify unusual values that deviate from the normal values or normal data points in the data set. Correlation analysis, where we'll check the relationships between variables using correlation coefficients. Then handling missing values is also important part of EDA, where we will detect and address the missing data via imputation or removal. Then last, summary statistics. So key statistics that provide insight into data trends and nonsense in exploratory data analysis. So these are the key aspects. These are the three types of exploratory data analysis. We are having first univariate, where we will examine the one variable at time to summarize or describe it and look for the patterns in the data. Like for example, studying the heights of the players. So height is the parameter or variable that we can analyze for the players. Second, we are having bivariate type of exploratory data analysis where it will involve two variables and it will focus on a relationship or association between these two variables. For example, ice cream sales versus outside temperature. So we will analyze the impact of one variable on the another variable here. Next type is the multivariate exploratory data analysis where data sets in the dataset, each observation consists of multiple variables or features. So the example is revenue based on the multiple expenditures. So these are the types of exploratory data analysis. There are two important techniques for exploratory data analysis. So most of the techniques are graphical in nature and few techniques are quantitative, that is related to the numbers. In quantitative type of exploratory data analysis, we use descriptive statistics where we can calculate the statistical measures like mean, median, and mode, variance, standard deviation, and range. And in graphical method of EDA, we can use different types of charts like histogram, scatter plot, then we have bar chart, line chart, and box plot. So these are the two major categories like quantitative and graphical methods for exploratory data analysis. Then challenges and best practices for exploratory data analysis. So we have few common pitfalls for the exploratory data analysis or overall data science process. First is a very important, that is overfitting of the data. In this, model works only on the training data and it will not consider the testing data. So whenever we'll give testing data, it will give us a poor accuracy. So how to fix this overfitting? So for this, we have cross-validation method and regularization methods. Those will take care of overfitting in the machine learning model or data science. Then next, ignoring data quality. So we can say garbage in and we'll get output as a garbage only. So for this, we will need rigorous exploratory data analysis and outlier handling so that we can take quality of data for the data science of machine learning operations. And the next black box model, that is the explainable things are required, explainable predictions are required so that we can easily identify the patterns. So for that, we can use SHAP and line interpretability methods for explainable predictions. So best practices will start with the simple models like linear models, and then we can go advanced like deep learning models. We can document the assumptions and then collaborate with the domain expertise. So these are the best practices. Next, we have key takeaways for this session. So through this particular session on introduction to data science, these are the key takeaways. So we have understood that data science combines statistics, computer science, and domain knowledge. Domain knowledge is business knowledge, we can say, to turn raw data into insights. Nearly every industry like healthcare, finance, and retail relies on data science for efficiency and prediction. Python dominates in the field of this data science through its simplicity and rich ecosystem of libraries or packages like Pandas, NumPy, and Scikit-learn. Then we have understood the data analytics process, moving from defining objectives, collecting, cleaning, modeling, and sharing the insights. And the last, exploratory data analysis, it is the essential step, or we can say first step, where we can use quantitative or graphical techniques to understand the data before modeling. So these are the key takeaways for the sessions on introduction to data science. So thank you for watching this. In the next video or in the next lecture, we will start with some advanced topic from the data science. Thank you.